So in this particular problem, we're going to apply concepts of Pascal's principle, which says if you have a fluid enclosed in a container, the force applied on this thing, the force applied on the fluid gets distributed equally in all directions by the pressure that's exerted upon it, or the pressure gets distributed equally as a result of the force that's acted upon it. So the pressure on this side, I'll call P1, has to be equal to the pressure on this side of P2. If this is a fluid of some sort inside this container, if I push on it here, the force gets automatically transferred over here, but it might be different because dependent upon the surface area of each of these respective things. Now in this problem it's different because we're told the mass of the piston itself that does the moving is negligible. However, the mass of the larger piston must be considered. In addition, there's an object resting on that. So the force on piston 2, as we'll call it, is actually found by adding up first both masses of each piston and then multiplying that by the acceleration of gravity, 9.81, to get the force. So let's go ahead and do that. To find the force, well, on this side here, we have to take the 750 kilograms, add that to the 1584, and then multiply that by 9.81. And when I go through and do this calculation, I actually end up with 22,897, we'll call it. 22,897 newtons. That is the total weight that is experienced by this apparatus on what we'll call piston 2. The area of piston 1 can be found by using the equation of the area of a circle, and that's pi r squared, and the radius of this piston in particular is 1/10 of a meter. So if you were to do this, 0.1 squared is, I believe, 0.01. So you're dividing pi by 100. So basically, you get 0.0314 meters squared for what we'll call area 1 over here. I want to know what force is required on this side to move this mass. To find the area over here, call this A2, same deal, pi r squared. A2 equals pi times 1.7 squared, and when we go through and solve for that, I end up with 9.08, we'll call it, meters squared. Now, here's where we relate, since Pascal's principle says these pressures are equal on opposite sides, P1 equals P2. Pressure is defined as force over area. So we need to solve for F1, which we cross multiply the area 1, because that's what we need to do. If you don't like it, plug in numbers and do the same thing, but the process is unchanged. 22897. So we're taking 0.0314 times 22,897 and dividing that by 9.08 meters. And when we go through this process, we end up with an answer of 79.2 newtons as the force being responsible to apply to the smaller piston if we're to move it any larger distance.